All right. Hello, everybody, and welcome to the February 19th, 2022 iteration of the Hyperlight community meeting. This is the second meeting here, so I think we're still kind of getting into the swing of things, but welcome everybody. I will mention that as of right now, this project is governed by the Microsoft open source code of conduct. So there's a link to that and code of conduct we use for the Hyperlight devs here. So I just wanted to call that up before the meeting starts. And these meetings are recorded. So if anybody isn't comfortable being recorded or, yeah, I mean, feel free to contact us in other ways or keep your camera off or whatever. Just like to highlight that for some folks. Um, yeah, and as Ralph said, anybody who's new here, please feel free to add yourself to the attendees list. Um, for this meeting. And yeah, we can do a little bit of introductions. I think Ralph is doing some. Does anybody have any announcements outside of the introductions? I think only thing I wanted to announce was that there was a Hyperlight was discussed at Tag Runtime 2 weeks ago, but after the first community meeting here. So I think because of that too, we'll probably discuss that as part of the agenda. So as Ralph mentioned, since we are new here, we can do some introductions. I can start since I'm the host. My name is Mark Rossetti. I'm a software engineer at Microsoft. I work on Hyperlight and a bunch of other CNCF related projects. I think we've got mostly folks from Microsoft here who work on the project too, but I do see some new faces. So yeah, if you're comfortable, it'd be great to introduce yourselves and anybody who's at Microsoft. Ralph, do you want to go?
Yeah, I'm Ralph Kalachi. I'm a principal product manager in Azure Core Upstream, responsible for Hyperlight in theory, in reality, just management overhead to the engineering that's going on here, and also part of what Microsoft does with WebAssembly that is not in the browser.
Awesome. Anybody else would like to introduce themselves?
Yeah. So I'm Doro. I'm with Microsoft and I work at the Hyperlight project. I've been here for a few months, so I'm enjoying it.
Awesome.
I guess I'll go next. Dan, also one of the core maintainers for Hyperlight with Microsoft as well. Work on WebAssembly and other things upstream, but primarily Hyperlight.
Awesome.
I can go next. My name is Ludwig. I am from Microsoft as well, and I also work on Hyperlight.
I'll go next. I'm Brooke Hamilton. I work at Microsoft in Azure in the CTO office, and I work on Radius. And I'm just super interested in what Hyperlight is, and I'm excited for this project. I think it's really cool. So thanks for having this meeting.
Yeah, welcome. Thanks. Glad to see new people here too. So yeah, definitely let us know if there's anything you'd like to dive deeper into in the meeting or anything you're interested in. We can kind
I
of
can go
tailor.
next. Yeah, sorry. Can you guys hear me?
Yep.
Okay. So hi, my name is Manoj. I already talked to Dan a little bit before this meeting. So I also work at Microsoft, but my team is different. I'm like in Azure hardware side mostly, but I was really interested on the Rust and the Hyperlight and some other product similar to what, not similar, but kind of we use Rust for the different things. So I saw this project Reddit about the VM Hyperlight VM, how you guys executed the code in a very small time. So I kind of looked at the page, interested it, saw the project, it's open source, so kind of opt in. So today is my first meeting and really excited to help and contribute whenever I can. So yeah.
Awesome. Yeah, I think we're always looking for new contributors too. This project has been around for a while, but it's relatively new to open source too. So definitely let us know if there's anything we can do to improve the like experience, onboarding experience and everything and docs and all of that too. It's really great to see people. Is that Ralph that's struggling with the agenda? But yeah. Cool. Okay, I think that's so a round of introductions and announcements. I think we can get into the I guess first is, do we want to nominate somebody to do issue wrangling for the next week or two? That's mainly just going through the new issues that come up on GitHub and making sure that they're tagged appropriately and not
Yeah.
necessarily doing the deeper triage, but looping in the right folks.
I can take it this week.
Okay, awesome. Thank you, Dora.
Yeah. And
Now,
if you want, I can join as a secondary. So like learn it,
Sure.
how to do it, and then maybe in the upcoming weeks I can be primary, just to know how you guys
Yeah.
tag in as a. Okay. Sounds
okay,
good.
yeah, that would be great. I do believe that there, I don't know if it's done, but I think Lucy was working on some documentation for how we wanted to better like handle issues. We'll make sure to get that link out if that's done. But yeah, well, feel free to reach out in Slack too, or we'll post it in Slack too once that's done, and we can coordinate in Slack too.
Sounds good. Thanks.
Thanks. Discussion items, some blogs. Is this you, Ralph?
Yeah, I just put that in there for the record for people who, haven't read everything that we published about it. If you're interested, I also wanted it in the community record just so that if people look in the meeting notes, that they do see those things and just can say, oh, I didn't read that one or whatever it might be. So they're just there. They're not really discussion items in that sense.
Okay, awesome. Yeah, I know I've seen these, but good to highlight these. Next, I added a discussion item for the Hyperlight tag runtime discussions. I think that happened, like I said, last Tuesday or 2 Tuesdays ago, February 6th. I unfortunately wasn't able to join, and the meeting just got uploaded yesterday. Is anybody who was there? I was hoping David would be able to join. Ralph, were you there? Do you want to say, do you have any comments on that, how that went?
Sure. I'll type in a few more notes, but basically, it went extremely well in the sense that when you first explain Hyperlight, or like if you just read the blog or whatever, even though we're trying to explain things in language that people understand, there are a lot of things that are unusual about it. And so it's very easy to not quite be clear. Wait, you're saying this, but is that really what I think it is? And so forth, that kind of thing. So when we applied for the sandbox, the conversation in the issue was basically questions about how this was built and really does it do this and kind of thing. And then they asked for a tag runtime meeting, and we expected to clarify a lot of those questions. We ended up, of course, talking about those things, but actually that wasn't it. It was really a kind of was scheduled for, what was it? It should probably have been like a half an hour, maybe 20-minute section of the runtime. We ended up talking for an hour and a half. And it was a rich, enjoyable conversation about engineering. So it was so long that I had time to start Dan's demo, which is in fact the second link in the blog post there, creating the demo blog post. And got that running and showed how that worked, and that went off really, really well. So everybody was really, really interested in the project. It was great feedback, very interesting. So this is what you're looking at right now is the demo that I ran. Dan, you were there. Ludwig, I think you were there. Doru, you might have been there. Does that sound about right as a short description?
Yep.
Yep, I think that sounds right. I guess people asked, if I remember correctly, about containers and sort of running containers in Hyperlight,
Yep.
which I think is the common question that we get.
Yeah.
Comparisons to Firecracker, I think are common. So yeah, lots of good discussion, I think, coming from those questions, and they even said they might want us to go back, which was exciting.
Yeah. So I mean, when somebody says, "Hey, I want to come back and see more," and they're kind of reviewing you, you have to know that you've really interested them, which is fantastic. So end result is that we now go back to the agenda in the CNCF TOC. They get to schedule us at their leisure. So we're basically just waiting for them to put us back on the agenda to vote. with a tag runtime, a summary from the meeting and tag runtime. So that should happen, I would assume, not necessarily in February, but I would assume sometime in March, with our hope. It would be great to be in the sandbox when we get to KubeCon. That would be really cool.
Awesome. Yeah, and I did link to the recording. I think I timestamped it, and
Yep.
yeah, it was longer than some of the other tag runtime meetings, so I'm going to watch that probably after this.
Yep.
On that.
You can skip forward liberally because it really was an hour and 20 minutes.
Yeah.
So feel free.
I can do like 1.5x speed or anything.
Yes.
Awesome. Yeah. Does anybody have any other comments on that? It sounds like it was a pretty engaging conversation. I see a KVM guest debugging demo. Was this you?
Yeah, it's from me.
Awesome. Do you want to share your screen? I can shop.
Sure.
Okay, let me know if there's any issues with the screen share. I think it's set so everybody, anybody should be able to share.
Let me know when you see something.
I see, yep, VS Code with a...
Yeah.
Okay.
Awesome,
yeah, take it away.
Sure. So I'll start from the beginning. So what is the state now with how running a guest, and when you run into errors, how do you debug it? Well, the only solution we had and we have so far is you add some logging and printing in the guest, and usually you look for those messages and try to figure out what's happening. So we wanted to improve the overall experience of the development phase. And for now, we're working on adding Hyperlight KVM guest debugging. What does that mean? It means that, well, one would be able to debug Hyperlight sandboxes that run KVM guests. This is part of a broader effort to improve operational experience. So there will be some additional tasks that will target a different hypervisor, MSHV, for example, and also adding some core dumping and something like that, crash dumps. So as features, for now, what this supports is adding and removing breakpoints, reading, writing memory, reading, writing registers, stepping and continuing, and the guest automatically stops at the entry point for the user to do whatever he wants. Okay, so the demo I will show you is run on top of the Hello World application we have in Hyperlight. And in addition to the Hello World, I added the configuration for the debugging, which, as you can see here in the get sandbox configuration function, what it does when a feature I defined called GDB is enabled, the Hyperlight sandbox created will enable a GDB a GDB server that listens for connection in order to set up a session, a debugging session. Okay, so what this demo will do is it will set up a sandbox that has enabled debugging, and it will call print function. The host will call a print function that is print output function called print output function that is inside the guest. Okay, so let's start. So I will run the example. The example is called guest debugging, and I enabled the GDB feature so that the code you saw will be enabled. What happens here is an open port, the configured port here, will be opened on the local host, and a GDB remote session can be started on that port. So it will wait for a GDB connection to be established. So to establish a GDB connection, I configured my VS Code here with uh, a GDB configuration that would run on my WSL machine, and will connect to localhost 8080 port, the same one I configured in the host application. So when I run this configuration called GDB, as you see here, what will happen is it will stop by default at the entry point in the guest. And from there, the user can set breakpoints or do whatever he wants. So for example, if I want to step over, I can add a breakpoint here, for example, and continue to there. To show you that when calling the guest function from the host, it will stop here. I will add a breakpoint to the print output function that we have defined in the guest. It should be somewhere around up here. Okay, this is the function print output. And when I continue with the execution, it will stop here due to the host calling this function. What this function does, it actually calls back into the host to get access to print the string, as the guest doesn't have access to syscalls or something like that. It does everything through the host application. So if I step over this function, you will see the message below printed on the terminal, and I can continue, and it will finish execution. Okay, this is pretty much it from in terms of demo. I hope I didn't forget anything. Questions if you have.
Ralph, your hand's raised. Go ahead.
What's that, Mark?
Oh, I see your hand is raised. Did you have something
I
to say?
know.
We can't hear you. Hey, Ralph, we can't hear you if you're
Maybe. I think
talking.
his video stopped too.
Yeah.
No, this is awesome. I know that I've tried to debug some of the guest code in the past, and it was not fun. It's a little bit easier to do on Windows because you can get. Oh, Ralph, you back?
Back.
But wait,
Oh, he
back, but then
disconnected.
gone. But this looks like way easier just to be able to set a breakpoint and go in. Okay.
Yeah.
Rejoined.
Yeah, what I wanted to mention is that I added a documentation here that explains how to set up this VS Code example also, and if one wants to do it in the terminal using GDB, it contains example for doing just that. And also for development purposes, I added a diagram here that describes how the interaction internally is done in order to enable this. Yeah.
Yeah.
I can try again.
Go ahead.
Yeah.
My connection fell over. Of course, this was not a Zoom problem, but a Ralph problem. Forgive me. So this is fantastic, though. I love to see it. The diagram is incredibly useful. The work that you took to put that together, despite the fact that you use Mermaid, is still really, really useful to other people. So I want to thank you very much for that. The demo is really cool. I love your launch.json.
Yeah,
The
thanks.
the interesting thing is that for this demo, you're jumping into C, which means you don't have to swap debuggers or protocols or any of that kind of stuff. What would be really, really fun is when we, like, for example, the JavaScript stuff that can be done here, or the WebAssembly stuff that we'd like to do,
Yeah.
right? It will be fun to, how shall I say this, work with you to make sure that the nested debugging gets wired up in a way, and that'll be something that would be really, really fantastic
Yeah.
to show people that we can do. And you've done the fundamental work here. You walked right
Yeah.
into the function. That's fantastic.
Yeah, we
It's fantastic.
definitely have that in the queue, enabling WebAssembly and JavaScript. Yeah, that would be nice.
Fantastic. That's great.
I also need to mention this. I tried it in code spaces in GitHub, and it works. So one can do that completely in the web browser.
Oh, that's doubly cool.
Yeah, that is awesome.
Mhm.
Ludwig, did you have a?
Yeah, I just have a question for Doro. So I saw in the docs there's hardware breakpoints and software breakpoints, and there's a max of 4 hardware breakpoints. So how does that difference, like, what's the difference to the user there, or do they need to do anything about that?
Uh, Usually they don't need to do anything because from what I saw, implicitly software breakpoints are used.
Oh, I
However,
see.
if software breakpoints aren't supported, but we do support it, it goes to hardware breakpoints, which is a hardware related thing, and that's why we only allow a maximum of 4. It's related to the x86 architecture.
I see. So since we support software breakpoints, we could just do as many as we like.
Yeah.
All right, sounds good.
Yeah, one more thing I need to mention. So this is the work done in an open pull request now. I think there will be some small modifications that will improve the overall functionality, but we should have this merged, or at least the plan is to have it merged until next week. So, yeah.
Is there a chance you could drop the PR you're working on into the chat so that people can look at it?
Yeah, sure.
Or in
Can do
Slack.
that.
Yeah.
Yeah,
Or
I think it's
Slack.
better.
Slack is more persistent.
Yeah. I'll drop it in on Slack.
That'd
Okay.
be cool.
Yeah, awesome, man. That's great work. I think that'll
Thanks.
really help the development of some of the future like guest work that we have coming down the pipe. Yeah. Does anybody have anything else? Any other questions for Doru? I think I'm excited to give that a try.
So, sorry, one question. So Doru, you mentioned at the end that it also works in the GitHub code spaces. Is that correct, right?
Yeah.
Okay, that's awesome because sometimes I have to do on the GitHub workspaces so I can switch back and forth with different machines. So this is great. Thanks.
Yeah, sure. If you encounter any issue, just ping me and we can solve it.
Sure. Thanks.
Okay, then. If no other questions, I'll stop sharing.
Yep.
Thank you.
All right, and I don't see anything else on the agenda. Does anybody have anything else they want to discuss briefly now? Or if not, we can end. I think we're about on time. Anyway.
The only thing I would like to raise, because we have Manoj and Brooke here, if you haven't looked at the project in GitHub, definitely do that, because it will end up giving you some. First of all, you'll get a kind of a high level view of the big rocks that we're trying to tackle in the next few months, in particular. And then, in addition to that, it probably will, cause you to ask more questions, which would be fantastic. And those kinds of things that you look at there and that trigger questions are the things that we probably need to think about. So either have an explanation or create one, or just fantasize and lie about stuff, like something. So if you haven't seen that, do look.
Sure,
Hey, Rob.
absolutely. Actually, I tried running the few test cases like Dan helped me last week, and I'm looking at the code bases and also trying to look at some of the open uses. So that definitely helped me. But yeah, once I get more idea, probably I'll ask like more
And
question. But yeah.
fantastic. There are the reason I raise it is because in the project there are things like POSIX like APIs and things like this that are really big rocks. The actual implementation is not going to be what most people think, because there are absolutely fantastic, open source VMMs that have full POSIX support and so forth. That is not quite what we're doing. So if you read that and you think, hey, I'm going to have full POSIX inside a super fast memory partition, it's important to realize that we're not targeting that, because then you'd lose Cloud Hypervisor or Firecracker, or one of these, or build you something out of Rust VMM or something like OpenVMM. These kinds of things are for people who expect to get a full operating system environment for themselves. So just note that, and then ask the questions here or in the Slack, and we'd be happy to go through any of those issues and clarify, what we're trying to do and what the use case is. It's super useful.
Yeah, sounds good.
Project is fairly low level, and so we want to make sure that we kind of set clear expectations of what the project is aiming to solve and not solve too. So any like feedback on documentation that we have, I think the blog posts that Rob linked are hopefully do a pretty good job explaining all of that too, but definitely open to suggestions for improving that, making it more clear to everybody.
Yeah. Once you add like light on the Hyperlight, you have to set the expectations. So I understand, because sometimes people say it's this, but I want everything, but then you put everything, then it defeats the purpose. So
yeah,
I understand. I hear you on that.
Yeah. And when we were at the tag runtime meeting, we essentially circled around the conversation. People would understand, and they would sort of lose track of understanding, because one of the fascinating things is you'd be talking about, like, this is really a virtualized process, right? And you'd explain why, and then they'd go, okay, I get it. That's great. And these are super talented people, right? And then 15 minutes later, they'll be like, yeah, but I got a file. I'll just open a file and stuff like this. And you're like, whoa, wait. That implies file calls, which are usually OS level things, and we don't have those, but we need to make them possible, but in a different, so you start diving into the conversation again. So forgive me if I'm being heavy-handed by, again, bringing that up and saying, look at it and feel free to ask questions, because we are in fact working on enabling more code with things like file systems and networking, but we are not going to do it with a full kernel. And so the POSIX roadmap item, for example, is really about like, what chunks do we enable in our special way that makes code easier to use from that environment. So it's not we're not doing a full OS, is the short circuited kind of way to do it.
Yeah, we're allowing things to run in a hypervisor partition, so anything else that we add on top of that brings it closer to like an operating system. We need to evaluate like speed, security, all of that. And
yep. But anyway, it sounds, Manoj, it sounds like you've already sort of got that thing, and Brooke, I hope that much is obvious too. But still, bring all the questions, even if you want to go over it again. We're happy to do it again, because it really isn't, the layer that we're working at here is like walking back in computing history 25 years.
Awesome. Yep.
That's really interesting, because we've the reason the project is so exciting in terms of its performance and its security approach is that we've gotten rid of a whole ton of things that are really, really useful, but slow down the whole process. And so that's a hard choice to make. So I'm expecting lots of people to have questions about it and so forth. So I just raised the issue.
25 years ago was 20 or 2000, Ralph. We had NT4 and a bunch of stuff back then. So maybe even longer.
Well, it may even be longer, because the real point is we are at the level where we're rebuilding an OS in functionality, and yet we're trying to add some degree of portability for code that is out there expecting, POSIX APIs and full distribution file systems and things like this. That's a very interesting space to be in, because it's not that we want to shy away from saying we're building an OS. We do not want to do that. But still, we need to enable code that wants to open a file, wants to save something, wants to make a network call, wants to hit a GPU. Those things still have to be built in a way that's easy to use, and without an operating system. Okay, well, now that's an interesting place.
Hey, Ralph, can you talk about just summarize where this technology fits into CNCF and cloud native world? Like, why is it a good fit for CNCF?
Well, actually, it's a great fit for CNCF generally. The reason being is because the approach of CNCF is essentially that code should be able to be executable in any location, and it's cloud native. But cloud really means API driven resources, right? And that could be a private data center. It could be my laptop. When we talk to like IoT and or industrial automation vendors, they're all like, hey, this thing is perfect to put on my robotics gateways, not like on the Leaf robotics, like, the Leaf robot, but rather on the node that communicates with all the robots, because right now that stuff is all artisanal native code. And of course that has a lot of attack vectors that just go poof when you talk about something like this. So the various kinds of clouds or computing environments that are API driven, Hyperlight is really perfect for. The fact that it is not a container is an interesting case, because we built this whole 12-year Kubernetes juggernaut kind of thing on containers. And again, when you go back in time to dive underneath the APIs, down to the hardware really, and begin surfacing that functionality in a different way, containers go poof. And what you end up realizing is that, I've always loved Jesse Frizzell's, there is no such thing as a container presentation. Containers are an operating system configuration. They aren't a thing. And so the fascinating part is that CNCF seems to be built on a kind of container idea. But if you look at it technically, containers are not a thing. They're just a configuration of a particular operating system. So that entire conversation, if you unwrap it, you realize that it's really about movable and secure compute anywhere. Containers were hard to bring to other operating systems. For example, BSD doesn't have it in the Docker sense, right? And yet all operating systems try to do things like that. And yet those operating systems are not in the CNCF because they didn't do Docker containers. And there are other systems that will never do Docker containers, can't do it. Windows containers is a very hard technical problem to solve because it is not the operating system that the original configuration was for. So in this sense, one of the interesting things is that almost all chips that we have, certainly AMD and ARM chips and RISC-V and other chips, have hardware protection configurations now that we can take advantage of as a first, what you might call a first party caller rather than a caller from way away in a dependency tree of code. So in that sense, it brings completely new mobile, portable, independent functionality to pretty much everywhere, and it allows you to use any hypervisor system, Hyper-V, MSHV, the OpenVMM stuff we've been dorking around with a little bit.
Real quick, Ralph, I just want
KVM
to
and
say
so
we
forth.
have 1 minute left and the meeting's gonna cut off because we're still
Go,
on a free
go.
account here. So no, I don't want to.
No. That's
might get
correct to call me out. Anyway, Brooke, that's a start.
Yeah.
We can
I
pick up
think-
the conversation in the Slack too.
Also,
Thank
like
you.
there is some work that we want to do for like a container shim to run Hyperlight workloads in like via container D so that we can expose it to technologies like Kubernetes more easily. There's some projects to run other like WASM runtimes as container shims, and those are under generally under container D and CNCF projects. So we feel like that's where some of like the directions that we want to also take the project for beyond just like a library to load too, I will add.